Dear students, welcome to lecture number 19. So, problem set 5. Determine whether the given points are collinear or not. Question number 2. And these 3 points are given with their coordinates. Now you will find, for finding out the points are collinear or not. It is not specified whether we have to verify this by using distance formula or we have to verify this by using slope formula. So surely I am going to opt the slope formula. I mean to say, if I prove slope of AB is equal to slope of BC, then B is a common point and these 3 points ABC will be collinear. Now let's see here. I am going to find out slope of AB. So labeling this A as x1, y1, B as x2, y2, and here we will find C as x3, y3. Then slope of AB is equal to slope of AB is equal to y2 minus y1 upon x2 minus x1. That is equal to y2 minus y1. The value of y2 is minus 0.5 minus 0.5 minus y1, that is 2, upon x2 minus x1, that is 1 minus 0, 1 minus 0. Naturally, you all know whenever two numbers are negative, we add them. So minus 0.5 minus 2 will give us minus 2.5. 1 as it is, so no need of writing it. So slope of AB is 2.5. Slope of AB is equal to 2.5. Now I'm going to find out slope of BC. Okay. So slope of BC is equal to slope of BC is equal to y3 this time, y3 minus y2 upon x3 minus x2. We are using slope formula only, but while finding out slope of BC, y3 minus y2 upon x3 minus x2. So minus 3, which is y3, so minus 3, be careful here, minus 3 minus of minus 0.5 minus 3 y3 minus y2, but y2 is minus and it becomes minus or minus 0.5, x3 minus x2, so 2 minus 1, 2 minus 1. That is equal to minus 3 plus 0.5 upon 1. That is equal to, now minus 3 plus 0.5, you all know it, which is greater number 3. What is the sign of 3? Minus. So we always subtract the smaller number from the greater number and we put the value sign of the greater number. So sign for the answer is of course minus, and 3.0 minus 0.5 will be 2.5. This is slope of BC. So next statement is as such, since slope of AB is equal to slope of BC, slope of BC. Point B is common. Point B is common. Therefore, since we got slope same, point B is common, therefore points A, B, C are collinear. So this is how you will find. We are going to use slope formula. We find out the slope of AB. We got it as 2.5 minus 2.5. Sorry, I forgot to place minus sign. So slope of AB as minus 2.5. We also got slope of BC as minus 2.5, and B is a common point, and therefore you will get points ABC are collinear. So this is how we got the points ABC as collinear. Now, second question. In this case also, we have to find out the same, whether points are collinear or not. In the second sum as well as in the third sum also, we are going to use slope formula only. So now in second question, sub question of question 2, second one is P1 comma 2. P1 comma 2. Next one is Q. 2 comma 8 upon 5, and R is given as 3 comma 6 upon 5. 3 points are there, P, Q, R. Coordinates of P 1 comma 2, Q 2 comma 8 upon 5, R 3 comma 6 upon 5. So label them again as same way as the previous one. X1 y1, X2 y2, and of course X3 y3. So I label the coordinates of PQ are as X1 y1, X2 y2, and X3 y3. The slope of PQ, slope of PQ is equal to y2 minus y1 upon x2 minus x1. This is our slope formula only. y2 minus y1, 8 upon 5 minus y2 minus y1, that is 2. I am going to write it as y2 minus y1, 8 upon 5 minus 2 upon 1. x2 minus x1 is 2 minus 1. Now let's simplify it by cross multiplication way. 8 ones are 8 minus 10. So 8 minus 10 upon 5 divided by 2 minus 1 is 1. Right on the side again. 8 ones are 8 minus 10 upon 5 is 1, 5 upon 2 minus 1 is 1. So 8 minus 10 is minus 2. Minus 2 upon 5 upon 1. There is no need of writing that one at all. So slope of PQ is equal to slope of PQ is equal to minus 2 upon 5. So this is how we got slope of PQ. Now I am going to find out slope of QR. So slope of QR is equal to slope of QR is equal to, now coordinates of R, which is the second point, x3, y3. So y3 minus y2, y3 minus y2, of course, x3 minus x2. We are using the slope formula only. So slope of QR is equal to y3 minus y2 upon x3 minus x2. Now what is value of y3? y3 is 6 upon 5, while that of y3 is 8 upon 5. So 6 upon 5 minus value of y2 is 8 upon 5 whole divided by x3 minus x2, that is 3 minus 2. 3 minus 2 is of course 1. Here denominators are same. We'll find 5 and 5. Okay. So we simply subtract the numerators. So we'll get it as that is equal to 6 minus 8. 6 minus 8 upon 5. That is equal to 6 minus 8. Common denominator, which is 5. So 6 minus 8 upon 5. 3 minus 2 is of course 1. So no need of writing that. So 6 minus 8 is of course minus 2 upon 5. So in this case, you will find slope of B2 is minus 2 upon 5. Slope of QR is also minus 2 upon 5. So we'll mention over here slope of B2 the slope of QR, that is equal to minus 2 upon 5. Point Q is common. Slope of PQ is equal to slope of QR, and that is equal to minus 2 upon 5. Point Q is common. Therefore, points P, Q, R are collinear points. Whenever you will find slope of these two lines same and point is common, straight away you can mention over there that P2 are collinear points. So here we finish the second sub-question of question number 2, as well as now third question. Third question is also same. I need to say sub-question 3 of question number 2. In that question also, we have to verify whether the given points are collinear or not. So you will find here question number 2, sub question 3. Now coordinates of points are given as L1, 2, L1, 2, then N5, 5, 3, and N8, 6. Same as that of previous questions. What we will do our first step as label them as x1, y1, coordinates of n as x2, y2, and coordinates of n as x3, y2. Now let's find out slope of ln. So you will find it slope of ln is equal to y2 minus y1 upon x2 minus x1. That is equal to, now y2 minus y1, in this case value of y2 is 3 minus 2, 3 minus 2 upon x2 minus x1, that is 5 minus 1. 3 minus 2 is 1 upon 4. So this is how slope of ln. Slope of ln is 1 upon 4. In the same manner, I am going to find out slope of m. So slope of mn is equal to slope of mn. For finding out slope of mn, y3 minus y2 upon x3 minus x2. Slope of mn, y3 minus y2 upon x3 minus x2. y3 is 6, y2 is 2 plus 3. So 6 minus 3, 6 minus 3 upon x3 minus x2, 8 minus 5, 8 minus 5. So that will give us 6 minus 3 as 3, here also 3. So slope of mn, slope of mn. Now naturally what happens this time? Slope of ln is 1 upon 4, 3 minus 2 is 1, 5 minus 1 is 4. While that of slope of ln is 1. So slope of ln, slope of ln is not equal to slope of mn, slope of mn. Therefore, points L, M, N are non-collinear. That is important. This third one is non-collinear because slope of ln is not equal to the slope of m. And if their slopes are not same, then you will find points are non-collinear. So 1, 2, 5, 3 and 8, 6. Okay, so these were the coordinates. So this is how we will find. Here we finished question number 2, in which we have to decide whether given points are collinear or not. So let's proceed to solve now question number 3. In question number 3, they have asked us to find out the coordinates of midpoints. Question is to find out the coordinates of midpoints, and we know the midpoint formula, that x1 plus x2 upon 2. We always use the midpoint formula as x1 plus x2 upon 2. So, question number 3, problem set number 5, question 3. Question 3 is, find the coordinates of the midpoint. Find the coordinates of midpoint. Find the coordinates of midpoint. Find the coordinates of midpoint of segment PQ. While P is having the coordinates as 0, 6 and Q is having the coordinates as 12, 20. Very simple. You all label the coordinates of P as x and y, coordinates of Q as x to y2, coordinates of P as x to y2, coordinates of Q as x to y2. So by midpoint formula, let mxy be the midpoint let mxy be the midpoint of segment PQ. Therefore, x is equal to x1 plus x2 upon 2. In the same way, y is equal to y1 plus y2 upon 2. x1 plus x2 upon 2, y1 plus y2 upon 2. This is midpoint formula. And we have taken point N as midpoint of segment PQ. Now x is equal to values of x1 and x2 we know. Value of x1 is 0 plus 12. So 0 plus 12 upon 2. 0 plus 12 upon 2. While y is equal to y1 plus y2. Now what is value of y1? 6 plus 20. 6 plus 20 upon 2. So x is equal to, if you add 12 plus 0, of course, you will get 12 only. If you add 20 plus 6, you will get here y as 26 upon 2. So 2 6 are 12, x is equal to 6. And we all know, if we divide 26 by 2, we get it as 13. So, coordinates of midpoint, and for sake of convenience, we have taken m as a midpoint. So, m xy, mxy 6, 30. So these are the coordinates of midpoint of the segment PQ. P is having the coordinates as 0, 6, x to y. Q is having the coordinates as 12, 20, x to y. So this is how you will find we have solved question number 3 of problem set 5. Now see here question number 4. Now in question number 4, find the ratio. Okay, please try to understand. In this case, they ask us to find out the ratio. And they have given us the ratio points. Now I am copying the question first and writing the question over here. So question number 4, find the ratio. question 4 is find the ratio in which line segment. Find the ratio in which the line segment joining the points points are given here. Find the ratio in which the line segment joining the points A3, 8 and B minus 9, 3 is divided by y-axis. By y-axis. So what condition is given? That this point is dividing segment AB and that point is lying on y-axis. So let the point of intersection be P. If this point is lying, please try to understand. This point is lying on y-axis. Any point which lies on y-axis, its x-coordinate is 0. So this point I have taken it as 0, A. Okay. And if I label it as x and point A as y, so I label this point P 0A as xy. Now we will find bisection formula. First of all, I will label A38 as x1 by 1, okay, and B minus 9, 3 as x2 y2. I repeat again, the given point of intersection of the segment joining A and B is lying on y-axis. Since that point is lying on y-axis, you all know that its x-coordinate is 0. So we will get it as 0, A. I label that point as, we'll find xy, A x1 y1, B x2 y2. So we know the section formula. So bisection formula, x is equal to mx2 plus nx1 upon n plus n. X is equal to mx2 plus nx1 upon n plus n. Our question is to find out the value of the ratio, that means n upon n. So let's see here. Value of x is 0. So 0 is equal to mx2. So I'll write n as it is. But the value of x2 as minus 9. So minus 9 plus nx1, n also as it is. But value of x1 Value of x1 is 3 upon n plus n upon n plus n. So what happened now? 0 is equal to minus 9n plus 3n. This n plus n, if we transfer entire element on left hand side, so 0 into anything is 0. So 0 is equal to minus 9n plus 3n. Try to understand. If I transfer the group of n plus n into 0, anything into 0 is 0. Now minus 9n to the left hand side becomes plus 9. And right hand side is 3n only. If I transfer 9n minus to the left hand side, it becomes plus 9n. So m upon n is equal to 3 upon 9. This n there only. If I transfer n to the left hand side, 3 is here only. So 3 ones are 3. 3 3s are 9. So n upon n is 1 upon 3. Question is, find the ratio in which the line segment joining the points A3, 8 and B minus 9, 3 is divided by y-axis. So this is how you will find the point on y-axis. Our final answer. Point on y-axis divides segment. The name of segment is AB. AB. In the ratio 1 is to 3. 1 is to 3. So this is how we will find that we have to find out the point which lies on y-axis divides the segment A. What is important thing over here? That the coordinate of any point which lies on y coordinate is same. If you take that precaution, you will get answer very easily. Now next question is, the point lies on x-axis. Question number 5. Question number 5. Problem set number 5. That point lies on x-axis, which is equidistant. So please see here, I am writing question here. Question number 5. That find the point on x-axis. Find the point on x-axis. Find the point on x-axis which is equidistant, which is equidistant find the point on x-axis which is equidistant from P. Coordinates of P are 2, minus 5, 2, minus 5 and Q minus 2, 9. Find the point on x-axis which is equidistant from P, 2, minus 5, Q minus 2, 9. let, please try to understand here, let the required point, let the required point is M. Very important to note that the point is on x-axis. If point is on x-axis, its y coordinate is 0. Very important to know this. Okay, so let the required point n a comma 0. So Pm is equal to, P is having the coordinates as 2 comma minus 5. N we have taken it as a 0. So x1 y1, x2 y2. Pm is equal to root of, by distance formula, okay, x2 minus x1 the whole square, x2 minus x1 the whole square, plus y2 minus y1 the whole square. This is our distance formula because it is given A is at equidistant from P and Q. So Pm is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. So Pm is equal to root of x2. Root of x2. What is value of x2? A. x2 minus x1, that is a minus 2. A minus 2 the whole square plus y2 minus y1 the whole square. What is y2? 0. What is y1? Very important. 0 minus of minus. Please remember here 0 y2 minus y1, that is minus 5. The whole square. So the next step is root of a minus 2 the whole square plus minus into minus will give us plus. Try to understand again. Minus into minus is plus, 5 squared is 25. So Pm is equal to, this is our equation number 1. Now Q is equal to, coordinates of Q are minus 2 comma 9, minus 2 comma 9, minus 2 comma 9, while the coordinates of N we have taken them as a comma 0, a comma 0. Same way, x1 y1, x2 y2. By distance formula, Qm is equal to root of x2 minus x2 the whole square plus y2 minus y1 the whole square. In this case also I use distance formula, x2 minus x2 the whole square plus y2 minus y1 the whole square. Substitute the values. x2 minus x1. What is x2? A. Be careful here. A minus x1 is minus 2. Minus 2. x2 minus x1 the whole square plus y2 minus y1, that is 0 minus 9 the whole square. x2 minus x1 the whole square, a minus of minus 2. So that is equal to. Next step is a minus into minus is plus. So a plus 2 the whole square plus minus 9 square. Minus 9 square is plus 81. Plus 81. So you will find Qn is equal to root of a plus 2 the whole square plus 81. Label is as 2. So what is our aim? Our aim is to find out the coordinates of M, A, comma 0. But we'll find they have given us what they have given us. This point is equidistant, very important. Our next step is since M, A, comma 0 is equidistant, from P and Q. Therefore, Pn is equal to Qn. It is given that point M lies on x-axis, but which is equidistant from P and Q. So Pn is equal to Qn. We know the value of Pn as root of A minus 2 the whole square plus 25, that is equal to root of A plus 2 the whole square plus 81. So we know here A minus 2 the whole square plus 25, while value of Pn, while value of Qn is A plus 2 the whole square plus 81. Squaring, if we square both the sides, the square sign from both sides will disappear. So A minus 2 the whole square plus 25. Only the square signs of is equal to A plus 2 the whole square plus 81. Now we are going to expand this by using the formula A minus B the whole square, A square minus 2AB plus B square plus 25 is equal to, expanding this by using the formula A square plus 2AB, that is plus 4A plus B square, that is 2 square is 4 plus 81. I expand this by using the formula A plus B the whole square. I expand this by using the formula A minus B the whole square. A square and A square will cancel from both sides. Reason being that if you transfer this on right hand side, it will become minus. So that is cancelled. Now minus 4A plus 25 plus 4, that is 29, is equal to 4A plus 81 plus 4 is 85. So 4 minus 4A plus 29 is equal to 4A plus 85. Now what I am going to do now, I will transfer this 4A to the left hand side and 29 on the right hand side. We have to find out coordinates of M. M lies on x-axis, which is equidistant from both the points. So next step is 29 here only on right hand side. 4A, which is on right hand side, if I transfer it to the left hand side, I will get minus 4. Try to understand this. 4A to the left hand side becomes minus 4. 29 on right hand side, 85. Minus 29. So minus 4A is minus 8A. Okay, minus 4a minus 4 is minus 8a is equal to 2. So the difference between these two is 56. 85 minus 29 is 56. We have to find out value of a. So a is equal to 56 upon minus 8. So you get a is equal to minus 7. So this is how you will find if we get the value of a. Our question is to find out the coordinates of n. We have taken the coordinates of n as a comma 0. Therefore, coordinates of n are a comma 0, that is n minus 7 from 0. So this is how you will find the point n, which is equidistant from points P and Q. I find out the distance Pn, Qn, I square both sides. Then here I expand it by using formula minus b the whole square. Right hand side I expand it by using the formula a plus b the whole square minus 4a on this side. This 4a minus 4a. 29 on right hand side. Minus 8a is equal to 56. A is equal to 56 upon minus 8. So coordinates of n are a comma 0. That is minus 7 comma 0. So dear students, you will find I finished my 19th lecture over here. Thank you.